As I mentioned in the last lesson, we have just one basic data type left to cover. However, today we are going to take a short break from data types and learn about arithmetic operators and expressions instead. You've already used operators in maths, so you are familiar with the basic idea. An operator is simply a symbol that tells us to perform an action. There are several types of operators in Python, but today we will be focusing on arithmetic operators. Python uses symbols to represent mathematical operations, although some of the symbols are different from those used in maths. The calculations themselves are exactly the same. We've already seen addition, subtraction, multiplication, and division. Now let's take a closer look at three more arithmetic operators. The first operator is floor division. Floor division divides one number by another and returns only the whole number part of the result, removing everything after the decimal point. The next operator is called the modulus operator. The modulus operator returns the remainder after a division. One of the most common uses of the modulus operator is checking whether a number is even or odd. The final operator is called the exponentiation operator. It raises a number to the power of another number. The first value is called the base, and the second value is the exponent or power. The idea of an expression is very similar to what you've already seen in maths. An expression is a combination of values, variables, and operators that Python can evaluate to produce a single result. Expressions don't have to contain only numbers. They can also work with strings and variables. For example, price times quantity is an expression because Python can evaluate it to produce a single value. Before we move on, there is one more important rule to remember. Python doesn't simply evaluate expressions from left to right. Instead, it follows a specific order to make sure calculations produce the correct result. You may remember using the word BODMAS at school. Python follows the same rules. I've used these examples to help you understand the order in which Python evaluates expressions. In practice, you don't want your expressions to become too complicated. If an expression starts to look difficult to read, it's often better to split it into smaller, simpler expressions, or use brackets to make your intention clear. As the Zen of Python reminds us, readability counts. Writing clear, readable code is just as important as writing code that works. Let's look at how arithmetic operators behave with the data types we've learned so far, so strings, integers, and floats. Some arithmetic operators can be used with more than one data type, but they don't always produce the same result. When you use the plus operator with integers or floats, Python performs addition. When you use the plus operator with strings, Python joins the strings together, so performs concatenation, as you remember. However, both values must be strings. If one value is a string and the other is an integer, for example, Python will return an error. What about multiplication? With numbers, it works exactly as you would expect. Strings behave a little differently. If you multiply a string by an integer, Python repeats the string that number of times. However, you cannot multiply one string by another, and you also cannot multiply a string by a float. In both cases, Python will return an error. Keep these behaviors in mind when writing your programs. Understanding how operators work with different data types will help you avoid common mistakes and produce reliable, error-free code. Please remember, operators perform actions, expressions produce values. Expressions can contain numbers. Expressions can contain variables. Expressions can contain one or more operators. Python follows the same order of mathematical operations that you learned in school. Once you understand expressions, you will find useful using them in almost every Python program you write. As I mentioned before, the Zen of Python reminds us readability counts. Even though Python understands complex expressions, your goal should always be to write code that is easy to read and easy to understand. If an expression becomes difficult to follow, don't be afraid to use brackets or split it into smaller steps. Clear code is good code.